Okay, let's unpack this. We are diving deep into the engineering magic that stops large language models, the engines behind all those chatbots,
Yeah.
from getting creative with the truth.
It's really the essential scaffolding for any kind of trustworthy AI. I mean, if you've ever asked an LLM a question and it just confidently make up an answer.
That famous AI hallucination.
Exactly. You've hit on the core multi-billion-dollar problem we're tackling today.
Right, and the issue is it's almost philosophical. These LLMs are pattern machines. They're trained on these huge, but ultimately static data sets.
The model doesn't know anything. It's just predicting the next word based on probability, based on data that might be years out of date.
Or just doesn't include your company's internal files, for example.
Which brings us to our deep dive. Retrieval Augmented Generation, or RJ. This technique, it just completely changes the game. It lets an LLM do a quick knowledge lookup.
A lookup before it answers.
Yes, it retrieves new external information from a knowledge base you provide before it generates a response.
So instead of the LLM just digging through its own vast but old memory,
Right.
our rig makes it grab a little cheat sheet that we provide. And only then does it use that specific data to build its answer.
It's a shortcut to being reliably well-informed, especially in, corporate settings where you need the latest policy or the most up-to-date numbers, and you don't have to retrain the whole model.
And what's interesting is this idea isn't brand new. It was first introduced in a research paper back in 2020.
It immediately showed a practical way forward, a way to blend the LLM's generative power with a super efficient document lookup. It moves us away from this idea that the model has to contain all knowledge.
To a model that's more of an expert reasoner powered by an external library.
Well, exactly.
So to really get why RAG is so necessary, we have to talk about the problem it solves. And it's not a minor bug. It's what people are calling the hallucination crisis.
And that crisis is rooted in what the AI is trying to do. It's optimizing for coherence, not truth.
Wants to sound convincing.
It wants to sound convincing, so it will always prefer to generate a confident-sounding answer rather than just saying, I don't know.
And the consequences for that have gotten, well, pretty severe. I'm thinking of that really stunning example with Google's Bard demo.
Oh, that was a brutal, very public stress test for the whole industry. It was supposed to show off how great Bard was.
And instead,
the LLM gave some wrong information about the James Webb Space Telescope.
it was a tiny error, right? It said the telescope took the very first pictures of an exoplanet, which it didn't. A fact-checkable mistake.
A tiny mistake with a colossal consequence. Reports said that one error contributed to a $100 billion drop in the company's stock value.
$100 billion.
That's not just a talking point. It's a warning flare. It proves that factual inaccuracy is now a material financial risk.
We've seen it everywhere. Lawyers citing fake cases, doctors getting bad medical advice. It just destroys trust.
But, and this is a really crucial nuance, RAG is designed to stop the model from making things up, but it doesn't solve all the problems, especially when it comes to context.
The context misinterpretation trap. This is the big aha moment for me.
Right, because we have an example where the RAG system worked perfectly. It found a factually correct source.
But the final answer was complete misinformation.
The AI generated the statement, the United States has had one Muslim president, Barack Hussein Obama. Totally false.
And when you trace it back,
book with the rhetorical title, Barack Hussein Obama, America's first Muslim president.
with a question mark.
With a question mark.
Right.
The LLM saw the names, it saw the sentence structure, but it completely missed the rhetorical nature of the title. It saw a statement, not a question.
Wow. So you can lead the AI to the perfect source, the absolute truth, but if it misses irony or a rhetorical question,
It can still generate profound misinformation. RAG is a superb guardrail against invented facts, but it's not an immunity shield against misinterpreted facts.
okay, so we've established hallucinations are expensive and dangerous, which leads us perfectly into the mechanics of RAG. How does this elegant solution actually work?
When we talk about RAG's benefits, accuracy is what gets the headlines, but the efficiency might be the most compelling part.
Because retraining these huge models is just brutally expensive, computationally, financially.
And it takes forever. Imagine you're a hospital and you update compliance policies every quarter. You can't spend millions retraining your AI every 90 days.
It's just not sustainable.
And this is where RAG shines. When new information comes in, you don't touch the giant LLM at all. You just update its external knowledge base.
So you're shifting from this massive, slow retraining of the model
To simple, fast data augmentation of the index. It's so much more agile. It basically democratizes access to this tech.
Okay, so let's walk through the process. It all starts with data preparation, right? Taking all our documents, PDFs, whatever.
Right. That data first has to be converted into a format for super fast semantic comparison. We call this embedding.
It turns text into numbers, a big list of numbers for every piece of text.
Exactly. And those numbers, the LLM embeddings, represent the meaning of the text, not just the words. So dog and canine will be numerically very close in that mathematical space.
And these embeddings get stored in a special kind of database.
A vector database. And it's optimized for this kind of semantic search, not old school keyword search. It looks for meaning.
So once the data is prepped and in the database, the user asks a question.
Yep. The user's query also gets turned into an embedding, into a vector. Then a document retriever compares that query vector to all the document vectors in the database.
And it finds the closest matches.
It finds the top few most relevant chunks of text. And this is the key that retrieved text is then fed into the LLM along with the user's original query.
That's the augmentation part.
Yes, through what we call prompt engineering. We're essentially stuffing the prompt with specific factual context. It tells the LLM, hey, for this question, prioritize this information over what you already know.
Prompt stuffing. I like that term. It's like giving the model a perfect little open book test.
And that leads to the final stage, the output. The LLM generates a fluent answer, but, and this is huge for trust, it can also include its sources.
Transparency. That's the big payoff. The user can see exactly which document snippets were used to create the answer.
It creates a crucial audit trail. A RAG response comes with live, verifiable citations. It turns the model from a confident guesser into a responsible citer.
So the mechanics are intricate, but the result is an AI that's cheaper, more current, and more trustworthy.
Yeah.
But it's not perfect.
Which brings us to the challenges RA still faces.
Right. If RA provides guardrails, what happens when the model still, swerves off the road?
We have to be realistic. RB is not a silver bullet.
No. Absolutely not. And the first limitation is that hallucination risk. It's reduced, but it's not zero. The LLM can still hallucinate around the source material.
How does that even happen? If you give it the perfect text, where does the error creep in? It's often in the final synthesis step. The model might cite the document correctly, but then it tries to be conversational and extrapolates a conclusion that isn't actually in the text.
So it's a failure of reasoning, not a failure of retrieval.
Exactly. And another big challenge is the model's self-assessment, or lack thereof. LLMs are really bad at knowing when they don't have enough information to answer.
You wanted to just say, I don't know.
You needed to say, I don't know. A confident but incomplete answer can be way more dangerous than no answer at all. But the model is designed to generate text, so it will.
And then there's maybe the biggest operational headache, conflicting information.
This is the reality of any corporate knowledge base. You have old policies, new policies, different drafts.
And the RG system might retrieve both.
It might retrieve both. And the LLM, in its attempt to be helpful, doesn't pick one. It tries to merge them. It combines an old rule with a new exception and creates a misleading hybrid response.
That sounds like a nightmare to debug.
It is, which is why engineers are working on improving the pipeline at every stage. And a huge focus right now is on that very first step. Chunking.
That's just how you break up the source documents into pieces for the vector database, right?
Right. But how you do it matters immensely. If your chunk is too big, it's full of noise, too small, and you lose critical context.
So what are the strategies?
Well, the simplest is fixed length with overlap. You just chop the text into, say, 500-character pieces. It's fast, but it's dumb. It can cut a sentence right in half.
Not ideal.
Not at all. So a smarter way is syntax-based chunking. You use a linguistic library to break the text up by sentence or paragraph. It respects the grammar.
Better context, but more work up front.
A lot more. And the most advanced is file format-based chunking. This is where you respect the document's own structure. So for code, you keep a whole function together. For a PDF, you keep a table or an image caption as one unit.
Maximum fidelity, but also maximum complexity.
It's all trade-offs. The whole RAG pipeline is under this constant pressure to get smarter, to get more accurate, to get more trustworthy.
So to wrap up our deep dive, let's bring it back to the big picture. Retrieval augmented generation is is clearly a foundational technique for using AI in the real world.
Absolutely. It bridges that huge gap between the static knowledge of a big model and the dynamic, specific facts we need. It hits the three big pain points: cost, accuracy, and transparency.
It makes AI cheaper, grounds it in facts, and lets us see its work with citations.
But even with all these amazing advances, vector databases, smart chunking, there's one final kind of fascinating reality.
Which is?
Sometimes the sophisticated semantic search just misses things.
And the solution to this super futuristic high-tech problem?
It's a throwback. It's hybrid search.
You're kidding.
Not at all. Engineers found that pure vector search is great for concepts, but it can miss specific keywords, a product code, a person's name, a specific date.
So to make sure they don't miss anything.
They combine the advanced vector search results with a traditional old-school keyword search.
So you run the smart semantic search to find the meaning, and at the same time, you run a basic keyword search to find the exact terms.
And you feed the combined results into the language model. It ensures you get the best of both worlds, the conceptual understanding and the precise, literal matches.
That's the perfect illustration of where we are with AI, isn't it?
Mm-hmm.
The most cutting-edge techniques still rely on simple, established methods to make sure they're robust.
It's like double-checking your complex spreadsheet with a simple calculator, just to be sure. The next big challenge isn't building new search methods, but making that hybrid integration completely seamless.
It really is. We've gone from AIs that invent things to AIs that cite their sources. But the fact that we still need a simple keyword search as a safety net, and something to think about. How often do we have to check the smart system with the old-school methods? Something to mull over until our next deep dive.
Indeed. The journey continues.
Until next time.